Regular physics, UT Quest problems, universal gravitation problem set, geosynchronous satellite. Here we have a geosynchronous satellite, and geosynchronous just means I have a satellite that orbits, and when it orbits, it stays over the exact same spot over the planet at all times, sort of like it's hovering. One of the things that a geosynchronous satellite has to have, along with many other properties, is it has to have the same time period as the satellite, as what it's orbiting. And that is basically what they're telling you here about the angular speed at this radius. Matches the rotational speed of the Earth, so they appear stationary in the sky, blah, 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 blah. What does that mean to us? What it means to us for this problem is this geosynchronous satellite is going to have a time period of 24 hours, same as it would on Earth in order to be geosynchronous. Okay, so this planet is similar to Earth, but not exactly like Earth. And the first thing we're going to say here, well, what is the force acting on the satellite? And the way we're going to approach this is we're going to look at Newton's second law. And if I can calculate the acceleration, because I do know the mass of the satellite, then I can get at the force. And that's exactly what I'm going to do. So let's take a look at acceleration centripetal. Let's see if we can get that number. Well, I know that is v sub t squared over r. Okay, now the r I have. Remember to convert that number into meters. All right, but the velocity, the tangential velocity, is something that I still don't have. All right, let's dig a little bit deeper into what tangential velocity is. It's 2 pi r over t. Now I'm in business. Okay, this orbital radius is what we can use for r. The time period is 24 hours. Remember to multiply that by 3,600, so that will give you 24 hours in seconds. And then that allows me to compute the tangential velocity. From the tangential velocity, I can get the centripetal acceleration, multiply the centripetal acceleration, and then by the mass, and then I have F net of one force. There's only the force of gravity acting on this satellite. Okay, now what is the mass of the planet? Now I'm just going to go to Newton's universal law of gravitation between two objects that are attracted to one another. And that's this equation. All right, I figured out from second law what the force needs to be. I know the mass of the satellite. I know the radius of the orbit. G is a constant, so I can just back calculate the mass of the planet, and I'm done with this problem.